Ladies and gentlemen, welcome to another video of my channel. In this video we are skyrocketing your basic Python skills. What will we cover in this video? You will get an expert with lists, you will master dictionaries, we will take a look at the iter and next function, and you will learn about string formatting. In the end, we are building an algorithm. I mean, how awesome is that? Before we are starting, if my video is helpful, consider supporting this channel by liking, subscribing and commenting. I thank you very much in advance. Let's get started. Let's take a look at some useful concepts for lists. You already learned how to create a list, and that was defining the list name and then using squared brackets and containing the elements comma separated. So for example, 2, 4, 6 and 8 here. List created, done. Let's print that out, done. So an alternative way to create a list is using the list function. Let's take an example for that. First we are defining a tuple here. And we are just typing down the values comma separated, or the elements comma separated. So for example, 1, 2, 3, 4, 5 here. Done, tuple created. And now we are defining the list name and use the list function to transform this tuple into a list. And therefore we are just providing the argument as the tuple here. So we are just containing t1 as the argument of this list function. And we've also created a list here. So if we're printing out that, we are getting the list. The next useful function is the append function, and that is just adding an item to the very end of a list. So let's take an example for that. We're using L2, which we just created, dot append, and now in the parentheses we are providing the element which we want to add at the very end of this list. That is also really important. So that is not doing sorting stuff or stuff like that. That is just appending at the very end of the list. So if we're taking a 6 here, and printing out the new list, we are getting the 6 at the end of this list here. The contrary function to this function is the remove function, and that is working in the same way. So we are using L2 dot remove, and then we are providing 6 as the argument, and now we are just removing the 6 again. If we are printing out the new list again, we are getting the list without the 6 now. An alternative way to remove items is the pop function, and that is working in a different way than the remove function. But first, let's append the 6 again. So we are using append 6 again and printing out this new list, and now the 6 is back on the list, okay? And now I want to use the pop function to get rid of the 6 here. So I'm using L2.pop, and now you have to provide as an argument the index value and not the element itself. So we know that 6 is at index 5. Why? 0, 1, 2, 3, 4, 5. Okay, so if I want to get rid of the 6, I have to provide the index value of the 6 here as the argument. So I'm providing 5 here, and I'm getting 6 as an output, and that is just telling me, okay, I have popped out the 6 here. So if we're printing out the list again, we are getting the list without the 6. So that is an alternative way to get rid of items in lists. The next function is the sort function. And that is pretty hard to show right now because this list, as you see, is sorted in an ascending order. And that is what the sort function does. But you can provide an alternative way to the sort function to sort this list in the other way around, so starting at 5, so a descending order. So if we are using the sort function by dot sort and use reverse equals to true as an argument, we are sorting this list in a descending order. So if we are printing out L2 again, as you see, the list is starting at 5 and ending at 1 here. Now we can actually use the sort function as it works without providing this argument of reverse, and that is done by sort and then just using empty parentheses, so no arguments at all for this function. And if we are printing out this list again, we are getting this list in an ascending order again. Last but not least, let's take a look at a very useful function, and that is the zip function. The zip function is taking an iterable object, for example a list, as an argument and is providing an iterator as an output. Let's take an example for that. So let's provide 2 lists here. The first one is containing the names. So for example, let's take Bob and Vince here. and the second list is containing their grades, so university grades or whatever you can imagine here. So Bob has a C and Vince has an A here. So we're executing that, and now we're using the zip function to assign C to Bob and A to Vince. So we're using zip and take names and grades as the arguments. And if we're executing that, we are just getting the information that a zip object has been created. So this information has for now no worth for us. So how can we work with this zip function? We have to use the list function before using this zip function. So we are providing list here, and then we are taking the zip function as an argument. So we are just using zip and then names and grades here inside those parentheses as the argument of this list creating function. And if we're executing that, we get what we wanted. So we have assigned C to Bob, and this is stored in a tuple in a whole list here. So the two lists have been merged into one list containing Bob and C and Vince and A as single tuples, as you see here. When we are approaching to dictionaries, you can also use dictionaries, and that is a way better use case to use this zip function. But nevertheless, I just want to show how this zip function is working. So how can you use it to operate with lists? And that is a pretty awesome thing here. So let's take an additional example here for the real use case of the zip function now, as we know how it works. So we are taking two lists here, and now we are containing numbers. So 1, 2, 3 here, and list 2 is containing, let's say, 2, 4, and 5 here, okay? And we're executing that, and now I want to do multiplications with those two lists, and I want to do element-wise multiplications. So for example, I want to multiply 1 times 2, 2 times 4, and 3 times 5, okay? And I can actually use the zip function to perform those calculations. How can I do that? I'm using a for loop for I.e. because I have two lists and thereby I have two iterators. For I, comma E, in, and then I'm using the zip function and take list 1 and list 2 as the argument of this zip function. Now I'm just providing the operation, and that is a multiplication, as we want to multiply each element with each other. So I'm providing I times E here, and of course I have to print that out. And if we're executing that, I'm getting exactly what I wanted to get. So I'm getting 1 times 2 is 2, 2 times 4 is 8, and 3 times 5 is 15. Perfect, right? We could also store these results in an additional list. So let's actually do that by defining a new empty list, list 3 here. And we're just creating an empty list by using squared brackets without any arguments. And now we're using the exact same for loop here. So for I, E in zip, list 1 and a list 2 here. And now we are just using list 3, so this empty list, dot append. And now we are just providing the operation, and that is a multiplication in our case. So you can use additions, subtractions, and every other mathematical operation here as well. So I'm using the multiplication here, and for executing that and print out list 3 here, I'm getting the results of this multiplication in an additional list. So that is pretty useful to merge lists with operations, okay? By the way, to professionalize your code and save some lines of code here, you could use list comprehension. I've covered list comprehension in a separate video, so be kindly invited to check that out or link it in the right corner and in the video description. But let's just type down the list comprehension way to do the exact same syntax as here. So let's define a new list, list 4 here, and now I'm using list comprehension. So I'm defining the operation here, I times E, and then I'm using the for loop for I in zip, list 1 and list 2, so this is not different from the syntax above. If I'm executing that and print out this list, I'm getting the same results in a more professional way. So again, be kindly invited to check out list comprehension. It's really helpful and it's getting your Python skills to the very next level. Next important one, dictionaries in general and some useful concepts. A dictionary is able to store a certain value to a specific key value. Let's take an example here. We are defining the name of the dictionary just as dictionary. And now we have to open up curly brackets. And inside these curly brackets, we have to define first the key value, and we are taking Martin here. And using a colon, define the value which is assigned to Martin. So let's just assume Martin is playing a game and has achieved 10 points. So we are assigning 10 to Martin here. Done. We have created a dictionary. So if we are printing out this dictionary, we are getting this output here. If we're using the type function of Python, we are getting the dictionary output here. So everything went better than expected. You could also store more than one key value to a certain dictionary. So let's just newly assign dictionary here and use a comma now and use the next key value. So let's just assume Bob has entered the game and has achieved 12 points. So we are assigning a key value here and use 12 points for this key value. So let's execute that and print out this one. So as you see, we have two values now, Martin and Bob, and two assigned values, 10 for Martin and 12 for Bob. To add entries to an existing dictionaries, we need the following syntax. So we are calling this dictionary by typing down the name, and now we are using squared brackets, define the key value inside them. So let's assume Lisa has entered the game. And now we are just using the equals to sign and define the points Lisa has achieved. And Lisa is quite good at this game, so she has achieved 15 points. And we are using this syntax now. And if we are printing out this dictionary now, we are getting Martin 10, Bob 12, and Lisa 15. So this is a syntax for adding new entries or amending existing entries. What's important to understand is that every key value is unique. So I can't add another Martin here. So I have to use Martin 2 or something like that. Or Martin and his second name or his surname or whatever. So if I want to amend entries, so let's assume Martin has a nice round and has achieved like 20 points. I can amend the value of Martin with the exact same syntax as above. So I'm just using dictionary, accessing the key value Martin, which is existent right now, and then I'm just assigning a new point value to Martin. So let's just take 20 here. And if I'm printing out the dictionary now, I have the new value for Martin. Okay? So again, you can't use Martin more than once. It is unique. Now, how can I get rid of entries? So let's assume Bob has left the game and he doesn't want to play anymore and he doesn't want his data to be stored in this dictionary. So he is telling us, please remove my data from your dictionary. That's no problem for us, as we can delete entries from dictionary pretty easy by just using the del function, then defining the dictionary name. So that is dictionary. And now we are using the key value which we want to delete, and that is Bob in this case. So we are just using del dictionary and Bob. And if we are printing out the dictionary now, we are getting the dictionary without Bob. So that's basically the most important things for dictionaries. Now let's take a look at an already used function which is pretty interesting in relation to dictionaries, and that is the zip function again. Now let's use two lists here again. We're using the same example as before. So we are using names here. And I think we used Bob and Vince, right? And Bob has a C and Vince has an A as a grade in a high school or in the university or whatever you can imagine. So we have a second list containing their grades. So Bob has C again and Vince has A. And now I want to achieve that Bob or that C is assigned to Bob and A is assigned to Vince. And I could use a dictionary perfectly here, right? Now I can use the already known zip function. So if you have skipped the list part of this video, please click the list part to understand the zip function here. So I'm just showing you that you can use this zip function with dictionary as well. And the dictionary function is dict in Python. And we are taking the zip function now again and providing names and grades as the argument. And as you see, we are getting a dictionary containing Bob as a key value and C as the assigned value to Bob and Vince as the key value and A as the assigned value to Vince. So that's pretty awesome, right? And that's it for now for dictionaries. Let's take a look at the iter and next function. Therefore, we are creating an iterable object, for example, a list or a tuple. Let's take a tuple here. We are defining x as 1, 2, 3. Tuple created, done. Let's print that out. We got a tuple here. Now let's use the iter function to create an iter object. And that is done by using the iter function and then provide x, which is our iterable object, a tuple, as an argument. And we are storing this in a variable which we are calling iterator. And if we are printing out this variable here, we're just getting the information that a tuple iterator has been created. Now, how can I work with this iterator? By using the next function. And that is working like this. You are providing the iterator as an argument of this next function, and you are getting the very first element out of this iterable object. So that is 1 here. And the interesting thing is now, if I'm using the next statement again now, I'm getting the second element. If I'm using the next statement again, I'm getting the third element. Now, what's happening if I'm using the next statement now, as there is no further element here? I'm getting an error message that the iteration is stopping here. To summarize the usage of the iter and next function, they are enabling you to get through an iteration step by step. Let's take a look at the very useful and time-saving concept of string formatting. Therefore, let us take an example. We have two variables here. First one is a name, so for example, let's say Julia here, and second one is her age. So let's take 25 here. Now I want to form a sentence using those variables. So for example, Julia is 25 years old. Without string formatting, I won't have an easy time to do so. But I'm showing you that you get why you should use string formatting. I would have to type down name plus and then is plus, and now I have to actually do a typecast of the age variable here. String of age plus and then years old. We have achieved what we wanted to achieve, but this is awkward, this is inefficient, and this is not good. And now we are solving this task with string formatting. And that is done in the following way. We are using quotation marks, and now we are working with placeholders. And placeholders are created by using curly brackets, like this one here. The first placeholder should be at the first place of the sentence because the sentence is starting with Julia, and Julia is our name variable here. Now we need to use is, and then using the second placeholder because age is in this position of the sentence, and then we are just using years old here. So we are not using any plus symbols or stuff like that, we're just working with placeholders. After the sentence, we are providing dot format, and now you have to be careful because you have to use the variables now in the right order. So the first placeholder is assigned to the very first argument of this format function. So we are using name here, and this is assigned to this placeholder here, comma, and then we are using age, and this is assigned to the second placeholder. If we're executing that, we are getting what we wanted to get in a way more convenient way, right? There is an alternative and, in my opinion, better way of string formatting, and that is using the f string. How does it work? We are using a lowercase f here, providing quotation marks, and now we're using again curly brackets, but this time we are containing the variable names inside those curly brackets. So we are taking name as the first one, and then is, curly brackets again, age, and then just years old, and ending the sentence with quotation marks again. If we're executing that, we are getting the same results. So this is even more convenient in my opinion. You can use whatever you like. So again, string formatting, very useful, very time-saving. At least have heard about that. To finalize this small tutorial series, we will build an algorithm. For that, we are using the sigma function or the sum function. This function is working like that. We have a starting value, which is 1, and we have an ending value, which is n. For example, if n is 5, we are adding up every value from 1 until 5. So that is 1 plus 2 plus 3 plus 4 plus 5. And this is resulting in 15. So the sigma of 5 is 15. Let us code that via a for loop in Python. First, we are defining the ending value, which is n equals to 5. Next is the for loop, and that is for I in range 1. So we are starting at 1 as we do in the function here, and we're ending at n plus 1. We have to provide the plus 1 because otherwise the 5 would be excluded. As the range function is working like that, if you are providing an ending value, the ending value is being excluded. Inside this loop, we have to reassign a certain variable by adding up the iterator. So we are just providing sigma here and use sigma plus the iterator inside this loop. I'm printing out the sigma in each iteration here to make this more clear. Outside this loop, we have to define sigma as 0. Why? In the very first step of this iteration, I equals to 1. We want to start at 1, and we can only start at 1 if sigma is 0, and we can add up a 1 to it so that sigma is actually 1 in the very first iteration. So this is a necessary step in this loop. If we're executing that, we are getting the value of sigma in each iteration. And every value until 15 is not relevant. The sigma value is actually 15. So this is the result. And this is right, as we see here. So this is perfect. But how does these iterations work? We are starting at 1, as we do here. Now we are adding up a 2 here, as this iteration is also doing. So this is 1 plus 2, and this is 3. So in easy words, these iterations are working as you would calculate these numbers. So you would start at 1 plus 2 and get a 3. You would then add a 3 and get a 6 in your head. Then you would add a 4 and get a 10, and then you would add a 5 and get a 15. Maybe you're saying, well, I'm a mathematical genius, I'm doing that in one step, but nevertheless, this is how this calculation is working. Now, let me give you one suggestion to even improve this code. You could use a function, a user-defined function, and that is done by using the def statement, providing the name of a function, and we are using sigma here, and we are using n as the argument. So my goal is that the user can call this function, provide an n value, an individual n value, and is getting the sigma value for this n. So that is easily done by just defining the sigma function sigma with the argument n, and now we're just copy-pasting this code from above and pasting that here, and now we have to care about the indentations, of course. This should be indentated here, this should be indentated here, and what we have to add is a return statement to get a value out of this function, and that is just returning the sigma outside the for loop. And if we're executing that and testing this function, so we are testing this with 5, we're getting the 15 as above, so this works perfectly. Let's test it for 10, this should give us 55. So this is a better way to use this sigma function.